Hi, so this is our third lecture on Matplotlib. So today we are going to discuss some more features or some more tools from Matplotlib. Particularly, we are going to work on plotting different kind of three-dimensional surfaces and various ways to project those surfaces on different planes. Moreover, I will discuss some practical example where we are going to take some real data and we are going to show how we can present that real data in more nicer and informative way using various techniques we have discussed so far. So let's get started. So first we are going to define a 3D surface, and then we'll see how we can plot that 3D surface in Matplotlib. So first of all, we have to import pyplot, and we also have to import numpy, because as we have seen before that most of the functions in Matplotlib, they work for array data. So import matplotlib.pyplot as plt. Similarly, import numpy as np. So let me just write in here comment. The surface I would like to plot here is it's a function of xy, and suppose that function is sine of x plus cos of y. So this function has two independent variables, and there will be third dependent variable. So when you draw this surface, this function, you get a surface in 3 dimensions. So on xy axis we plot x and values of x and y axis, and on z axis we plot function values. So let's say we want x to be x. First we have to define range for x. So x in this range -5, 5. Similarly, let's define y in, you can take any range you like, -5, 5. So this is going to be our x-axis and y-axis, and suppose we take, let's say, 50 points on x-axis and 50 points on y-axis. Then we get a, so when you plot these points on for your coordinate plane, you get a grid. So every point on that grid is an ordered pair. When you substitute that ordered pair here, you get the value of z on z-axis. So I hope you have some idea of these surfaces from your calculus course. So let's get started. So first we have to define x. So x is going to be an array, np dot line space, and here we want to start with -5 and end at 5, and then we want, let's say, 50 points between -5 and 5, and y is same as x, so we don't need to redefine y. We can just simply say y equal to x. Now let's define a function. So we are going to define a user defined function. So I would call func, name of that function, and it's going to take these inputs x and y, 2 arguments, and the function definition is a sine of x plus cos of x. So the function is going to return np. So everything is in array, so we have to use this np class, np sine x plus np dot cos of x. So we are done with this function. Okay, so now as we did in our previous examples, we have to create, in order to draw a graph in Python, you have to create a figure object and axis object. Let's do that. So fig is a figure object, and ax is the axis object. And how do we create them? We use this subplot function from pyplot. So this simply creates two objects, figure object and axis object, but this time we want a 3-dimensional axis. By default it creates a 2-dimensional axis object, but now this time we want it to create a 3-dimensional axis object. For that we have to pass a special argument here, and that special argument is subplot. So we are passing this argument by keyword. So this is the name of that argument. Keyword is equal to, so what we are passing is a dictionary. So projection 3D. So this means that we are projecting this axis in 3 dimension, or we are saying to this subplots that create an axis object which has 3 dimensions. So this is one argument we have passed here. You can pass here more argument as we did before. You can pass here let's say figure size. You can decide the figure size. So normally, as you know, normally it's 8 by 6 inches, And similarly you can define the face color and many other things you can define here, but I just want to skip those things because we already know how to work with them. So in order to plot a surface, there is a function which works for this axis object, and name of the function is plot underscore surface. So this function is going to plot a surface for us, and in order to get the surface you have to pass 3 arguments here. Okay, so before we work with this function, we have to create grids for x-axis and y-axis, because when we have created these x and y variables, these are just array values. We haven't created grid. So remember, we have discussed how to create a grid, two-dimensional grid, using mesh grid function from the NumPy package. So we define capital X and capital Y is equal to mesh grid to be created from x comma y. Actually, this returns set of ordered pairs. At this point, x and y are like 2 different vectors, but when you create a mesh grid, you get sort of ordered pairs. So now you can evaluate this function on these ordered pairs. So for more detail, please go back and listen to my NumPy lecture 1. So this is from NumPy library, so we have to start this with NumPy NP. Okay, so we have this mesh grid. Now we want to evaluate this function func on this mesh grid. So first you have to here insert x, then y, then f at capital X and capital Y. So this function is not going to work if you simply use x and y. You have to make sure that you create a grid. Okay, so this function is func. Let's save it and run it. So this function, this plot surface function, also takes many optional arguments. For example, you can decide the marker size, you can decide the color, and you can decide the face color. So many things you have here, and we have discussed those things in our previous lecture, so I just want to skip them here. So let's save it and run it, and let's see what we get. Okay, so when you run it, you get this graph. So this is just a graph of sine function in 3D, because I wanted to have y here, so I mistakenly put x here. So let's save it and run it again. Okay, so this is the 3D graph we get here. So you see that it's in 3 dimension, and so far we have not set any labels, x label, y label, and title of the graph. You can also set the color of the graph. So in order to set these labels and titles, you can use the same approach we did before. So ax dot, you can set x label. Here you may say that let's say x values. Otherwise you have to write the physical or realistic name of that x. In this example, we have just considered x and y, so let's stick to that. I would simply say that x values, and you can also increase the size of this label. So here you can have optional argument font size is equal to, let's say it's 10, we take it 10, and font weight is equal to bold, whether you want font to be a bold or plain. So this is how you set that, you use this keyword font weight. Okay, let's run this and see what we get. Okay, you see this graph. So these are your x values. Label, we have set the label. You can set the y label, you can set the title of this graph. Let's do that. You just have to copy this and paste it here, and here you have to change x with y. Similarly, you can set the title, or you can just simply set z values, label for z, and you can also set the title if you want for this graph, ax dot set title. So you may set this represents this function fx comma y is equal to sine of x plus cos of x. Now if you run this, you see that we have x values, y values, z values, and this is the label for this graph. You can also make it bold. Okay, now let's talk about the different colors you can have for this graph. So you have different choices. Either you can have a plain color, like here blue, you can change it to red, you can change it to green. So, but you can also assign a color map to this graph. Color map is actually a map from different values, different numbers to different colors. So in this case, the color map is going to be for the Z values. So we are going to assign, because the vertical values are Z values and the grid points are here on XY axis. So we are interested in assigning different colors to these values. You can set that color map for this graph. For that, you have to import a class here from Matplotlib import CM. So CM is for color map. So you can set here the color map of your graph. So the keyword for color map is CMap, and here you have to you can select any color map from this class. So you have to set using CM dot. So if you write dot, it's going to show you and tell you all kind of color maps available. Let's say if we choose this color map, or maybe this color map. So we'll save this and let's turn off the window. Then if you run this, you will see the color map for this graph. So now you see that these different colors are showing different values of Z. So you can also have a like bar here, color bar, that will show you what color corresponds to what value. Normally it is from in ascending order. So these, let's say the dark blue color shows you the lowest value, and this dark brown shows the highest value. These are values in between. So but you can also have a color bar here which is going to show the values for different colors. So in order to have a color bar in our graph, what we have to do is we have to assign this graph. This is a kind of object. So you can assign this graph a let's say FD to a new value, FD to a new variable. So FD is an object. Now what we want to do is we want to have a color bar on this object. So color bar is a method for figure objects. So you have to write here figure dot color bar, and in this function you have to pass this graph that you have plotted here. So FD, and there are some more things you can also set here, like properties of the color bar. You can set the ticks on your color bar, etc, etc. So let's leave it, let's only use FD for now. Then save it and let's run it. So you see that we have a color bar here which is showing to which number the different colors correspond. So 1.5 is the lowest, and the dark color is the highest here. So you can also set the size and its position, whether you want this here or you want this here. And for example, in this case, this seems a little bigger than this picture. So make it, if you want to make it look nicer, you can set the size of this color bar to be the same as the Z-axis. For that, we use an optional argument here by the name of shrink. Here you may shrink your color bar. The actual size, if actual size is 1, you may shrink it to, let's say, 70%. For that we use 0.7. For 80% you have to use 0.8. So let's run it. You see that now the color bar has a smaller size. So you can also set the text here. For example, the label, the numbers you want here. If you don't want to have all the numbers, you can decide which numbers you want to print here with the color bar. So this is also possible by using the tick option. So let's set the for this color bar, let's set the title and the ticks. So this is you assign this color bar to a new variable. So let's call it FC, means functions color bar. So you can have any name here. So we can use all the methods we have used before to set ticks and set labels. So I can say fc.set label. So what label this color bar is going to have, because color bar is showing the Z values, the function values, I can simply say Z. It's showing Z values, and I can also set the ticks, the values I want to show on the color bar. So set ticks. Here you can have a list of values you want to show on the color bar. Let's say I want just -1, 0, 1. So this, we are plotting this graph. It's a sum of sine and cosine, and we know that sine and cosine, they can't go beyond 1. So this is a reasonably good list of numbers that you can show on your color bar. You can change it to anything you want. So let's save it and run it. So when you run it, you see that we have this z. It's showing a z value. It's rotated z by 180 degree, and then on color bar we have just -1, 0, and 1. Okay, there are a number of different ways to draw these surfaces. How the surface actually depends on how you want the surface to look like. You want a solid surface, a completely filled surface, or you just want to plot to connect the different grid points by some kind of a wireframe. So that is also possible. So let's try to do that. For that you have to use the wireframe function for this function. So let's try that. Instead of plot surface, you can have I just want to comment this here, and let's copy this and paste here. So I'm just changing this plot surface to plot wireframe. So wireframe is a function, plot underscore wireframe is a function that is going to plot this data in wireframe form. So let's save this and run this. So when you run this, you see that there are like these squares have not been filled up, so you just see wireframe here. So there are a couple of different options. The way you want to see your surface, you can just explore that on your own. You can set the different colors here for this surface. Okay, let's stick with this plot surface, and okay, let's try some different color maps here. So let's see, I just want to have another color map. Let's say I choose this color map. This one is rainbow colors. Let's save it and run it. So you see that we get this color scheme, and you can also set the color bar as we did before and the text value. Okay, let's run it. Okay, you see this. You can make it even more smooth graph if you increase these values. We have taken 50 values from -5 to 5. If you take more value, then it's going to be more smooth graph because you are going to have more values on x and y axis. Okay, so there are other functions here in Python. You can use them to plot contours of different surfaces. Contour is simply, for example, if you cut this surface with a plane that is perpendicular to z-axis, the image you are going to get on that plane is called contour plot for that particular value of z. So you can have contour plots for all different values of z. For that we use a function, it's by the name of contour. So let's try that function here. So we just want to comment this part because we don't want, or maybe we can just keep it here so that we can make comparison with this function and its contour. So now let's define another figure and axis object. Now since contour plot is a 2D graph, so we just have to so we don't need to pass this argument here because we are going to now work with the 2D graph. So there are a number of different functions to plot contour plots. So I will discuss two, and I want to plot the output of those two functions on same graphic window. So I'm just using here 1, 2. 1, 2 means there's going to be one row and two columns. So on one figure object, we are creating two axis objects in a row format, that it is going to have one row with two columns. So every column is a different graph. So I want to demonstrate how different contour plot function we can use. So you simply have to use so the first function is called contour. So contour is the name of the function, and again it takes x, y, the function values. And this is func. Let's save it and run it. So okay, so this ax is an array. So there are two axis object, and when you have just one dimensional, when you create just one dimensional array of this axis object, so you can simply use the one dimensional indices here. So this is our first graph. So let's use another entry of that array, and Now I want to use another function. It's called contour f. So you'll see the difference between contour and contour f. So this also takes the same argument x comma y comma func x comma y. Let's save it and run it. So this time you are going to see, so when I run it, you are going to see two figure windows. One figure window will be created by this line, and on that window you are going to have a surface, and one figure window will be created by this line, and on this window we are going to have two axis objects, and for every x you have a contour plot. On first axis you are going to have this contour, and on the second axis you have contour f. Let's see what is the difference between contour f and contour. So save it and run it. Let's turn off this window first. So when you run it, you see two graphs. So you see here, these are the contour plots of this function. So different colors are showing different values. We can set the same color map that we have for this surface for these contours, so that we can make good comparisons. So let's do that first. So I'll just have a color map here. CM color map is equal to CM dot. So here we have used this GIST Rambo. So let's use that here. Or we can just copy from here. Let's say let's have the same for this function. Okay, and it's better to have this row wise. So I'll just write like this. There are two columns in one row. So now it will be rotated graph where the two graphs are arranged in a row y. Okay, just save it and run it. Okay, so you see that this is our 3D graph, and these are its contour maps. So the first graph is the graph from contour, and the second is from contour f. So see the difference. Contour f means you have filled the space between the contours. We have filled the entire region between the different contour curves. So this is the difference between contour f and contour. So you see that these different colors are showing different values. For example, if you look at this inner circle, it is showing that the value for this inner circle is this purple color. So this is showing the highest part of your graph. Highest part means if you cut, for example, this value is 1.5. If you cut this graph with a plane that is perpendicular to z-axis, then on this plane you are going to get this kind of curves. So this is what we mean by contour plots. Similarly, and for contours, you can set the color bar, you can set the labels, you can set the titles, all things that we have done for this graph. You can do the same thing for the contour maps as well. So this contour map is basically a projection of this surface on XY axis for different values of Z. These are all projections for different values of Z. But you can also have projection on some other planes. For example, you can cut this surface with a plane that is perpendicular to Z-axis. And similarly, you can cut this plane through a plane that is perpendicular to X-axis. That plane is going to be like this. And similarly, you can cut with a plane that is perpendicular to y-axis. So different projections are possible for different values of x and y and z. So let's try how can we have different views of this surface. So in order to see the projection of projection on different planes at different values of axis, we have to have again a 3D axis. So what we are going to do is we are going to define two different axes on the same figure object. On one axis we are going to plot the surface, and on the other axis we will plot projection of that surface for different planes on different planes at different offset values. So here I'm going to define this argument 2 comma 1. So 2 comma 1 means 2 rows and 1 column. So now we are going to have two figures in row wise. So now let's when you have one dimensional array of this axis object, you can simply use here just one index, like one dimensional array. So ax of 0, first figure is going to be this graph, so we have to insert 0 here, so we have to use this index 0 for all these values, 0, 0 and 0. So you may leave the color bar here for this moment, so let's leave it here. Now let's comment this part here. Now on the next axis, let's plot contour. So contour is actually projection of this graph on xy axis when z is 0. So this is a plane where z is 0. The plane perpendicular to z axis where the value of z is 0. So this is what we get through contour. But now we can specify different options to get different kind of contours, and they are basically projections on different planes at different values of the axis. So here it takes the same argument x comma y comma f x comma y, but now here you can set the direction on which direction your plane should be perpendicular. So here let's say we set x, and then you can set the offset. Offset is the value of x. Let's say we set value of x 0.5. Now when x is 0.5, we are going to have this plane which is perpendicular to x-axis at the value of x is equal to 0.5, and we can also set the color map. Let's use the same color map we have used it here so that it would be easier to make comparison. So let's copy it and paste it here. So this function is func. So now let's save it and run it, and now you are going to get one figure, and one figure is going to have two graphs. One graph is going to be surface, and the other graph is going to be the projection of graph on x-axis at 0.5. So let's save it and run it. So you see that so this is x-axis, so same is here, this is x-axis, and this is y-axis, so these are y values, and the vertical axis is z-axis. So you see that if you cut this surface through this plane, and that plane is perpendicular to z-axis, x-axis at this point, which is 0.5, and on this plane you get this graph. So this is projection of this graph on this plane, which is perpendicular to x-axis at x is equal to 0.5. You can change that here. You can change to y-axis, and you may set the value of y to be, let's say 0.2. Let's save it and run it and see what we get. You see that you get this graph. Now you see that so this is your y-axis. Similarly here is y-axis. So we are using a plane which is perpendicular to y-axis when you cut this surface. So when you cut this surface by this plane, that is at y is equal to 0.2, you get this image or this projection of the surface on that plane. So you can try this for different values on different axes. So this is how we can see the different aspects or different views of a surface. So this is all I wanted to discuss about 3D graphs. So there are many other optional arguments you can pass to these contour functions or surface functions. You can try that on your own, and they are not very difficult. It's a matter of simply using and seeing what happens when you use them. Okay, now let's talk about a more practical example. Now I'm going to get some data from a real life situation, and I'm going to use the tools we have learned so far to represent that data in a more informative way. And the data I'm going to take is the data of temperature. So there's a website. That website has data of temperature, like lowest temperature, highest temperature, and the average temperature for all over the world. That data comes in the form of CSV file. So let me just explain what is CSV file. So now we are going to work with a CSV file. So let's first comment this entire thing because we don't need these things anymore. We are going to commit from here to here. Let's save it. So CSV stands for comma separated values. So in that file, it's a text file. All the values are separated by a comma. It has a certain format. So the data we are going to get is going to be in CSV format, and Python has a CSV class and that has many functions which one can use to read and write data in CSV format. So we are going to have a file which is going to have temperature of a state or a city. The temperature values are going to be highest temperature, lowest temperature, and average value temperature. So we are going to extract the highest value of temperature and the lowest value of temperature, and we are going to plot that temperature date wise. So on x-axis you are going to have dates, and on y-axis you are going to have highest and lowest temperatures. So this is the website you can get data from. So I'll just copy the URL link and paste in that file so that you can use that when you practice. So you can collect data from this website. So how do we get that data? Let's see that. You have to go here in search tool, click the search tool, and here you can specify the kind of data you want. So let's say we just want daily summaries, we want data recorded on daily basis, and here you may suggest the dates. For example, it says that data from 1st January to April 17. You can select the date in any range, and then if you select by a city, then you have to enter the name of that city. For example, you can select by cities, and here you can write name, for example, Tokyo, Karachi. So let's say if you insert Karachi, you search, and then it is going to show this details. So this is Karachi region, and you have to click on view full details, and here it says that data type, temperature average, temperature max, temperature min. So this is going to be data recorded from your Karachi city, and there's a station list. Actually in cities there are a number of stations that record data. So there's only one station in Karachi, and that is Jinnah International Airport. So here you click, and then you add to cart. Add to cart is simply they don't charge you for data, but this is for free, but this is how they this is their procedure. So when you add to cart, so this shows here that your cart has one item, and you can click on this item. So we want data to be in this format, CSV. Click on this, and here you can set your dates. You want data from what date to what date, and then continue. So here there are a number of options you have to specify. So you want data by the name of stations, or you want data by the geographical locations. Let's stick to the name of stations, and here we just want air temperature. So we just click this and continue. So this is summary of your order. Here you have to specify your emails. So when you specify your email and you submit order, you are going to receive your data in your email. They will send you a link. So this is how you can data of temperature from all over the world, and you can use for your analysis. Okay, now let's come back to the file. So I have already downloaded data from this website, and that data is from the Tokyo city. Actually, when you download data, there may be some missing values. For example, if you download data of April, you might have values from April 1 to April 5, and maybe 6 values missing. So when you get data from these kind of sources, you have to first of all fix your data, because if you run your code on data which has some missing values, then it's going to show some exceptions. So we have to make sure that we take care of those exceptions systematically when we work with those datas. So for example, I have this file here. It's a Tokyo data. So I have named this file with Tokyo date underscore data name. But when you download your file, it's going to have some other name, so you can rename it if you want. So you see that the first line shows the titles. So station, so this is the ID of station, name of the city is Tokyo, and these are dates, and this is T max, T min. This is first is T average, then T max, and then T min. So these last three columns actually they represent recorded temperature in Fahrenheit. So the unit of this temperature is Fahrenheit, and the first column is max the first column is the average temperature, the second is max, and third is min. So we are going to work with these two columns, the last two columns. So let's get started. So in order to work with this data, we have to first call or import the CSV class, import CSV. We can work the functions available in the CSV class. So let's first open the file. So we know how to open the file. So let's first open this file. File is equal to open, and here you can specify the file name. So as you have seen that in this folder I have this file Tokyo_data. So I'm going to open that file Tokyo_data. So in order to read data from this file, we use reader method. From this reader method is a method of CSV class. So we use this reader method to read this file, and this reader method is going to create an object from this file, and let's give that object some name. So I would call that object file data, or anything you like, file data. So this file data is going to be stored in this object. Now this object is, okay, this has to be CSV, and this reader method, which belongs to this CSV class, returns this object, and this object is iterable. Iterable means that this object is going to have all the lines of data in this CSV file. So you can iterate over those lines. You can select the first line, second line, third line, fourth line. This is what we mean by the object is iterable. Okay, so if you look at this data, you see that we are not concerned with the first line. First row does not have any data. They are just title names. So we just want to skip the first line, and we want to work with the next line. So you see that all the values are separated by comma. That's why we call this file CSV file, comma separated file. So all the entries are separated by commas. So we are interested in the two last entries. So in the first line, this entry has index 0, this has index 1, 2, 3, 4, 5. So we have indices ranging from 0 to 5. So similarly for the next line, we have same indices. So we are interested in like 4 and 5 indices, and this date. So 0, 1, 2. Second is going to be the date. Third, fourth, fifth, they are going to be the minimum and maximum values of the temperature. So let's skip the first line. So we are going to read the first line. So there's a method called next. When you pass this file, this object, to this next method file_data, so it is going to read the next line of this data. So since we are reading the first time, so next line is your first line. So it's going to read the first line. Let's store that first line in some variable. So first line is, let's call it first line. So first line, as I said, the first line is going to be this line, and it has 5 values, 0, 1, 2, 3, 4, 5. So you can check what is in the first line. Just print the first line, print first line. Okay, save it and run it. Okay, I'm missing this extension here, the CSV. So the file has extension CSV. Now let's run it again. So you see that we get the first line. So first line is in the form of list, and every entry of the list is a string. So you may also check the first entry of that string. So you see that you get station. So using this information, now we can read the data from the next lines. So let's comment this part here, and we are going to read the data from all the next lines. So this has 0 index, 1, 2, 3, 4, 5. You see that we are interested in extracting dates, tmax and tmin. So date has index 2, and this has index 4, and this has index 5. So let's keep this in mind and work and try to extract the data. So in order to extract the data, let's first define 3 empty lists where we are going to store these 3 columns. So first list is, let's call it date, that's our list, and then you have high temperature, so this is an empty list. Then let's have a low temperature, this is also an empty list. Save it, and now we are going to iterate over this object. Remember, this object has all the lines, and we have already read the next line. That means we have already read the first line. Now if we are going to read from this file, we are going to start from the second line. Okay, let's use the for loop for line in file data. So in this file data we are iterating, and our iterative index is line. So all entries in this file are in the form of string. So when we read these values, we have to make sure that we convert these entries into integers. So let's say if we read the first line, so we want from first line we want fourth index and fifth index, but at fourth index the value you have is Tmax, the maximum temperature, but that is in the form of string, so we have to convert that into integer. Okay, so we want to read this line, this entry, and we have converted that entry into integer. So we have got, let's say if you talk about the first line, from the next line we have got this entry which is here. So we are talking about now this entry, this 51, which is the Tmax, but this was in the form of string, so we have converted that into integer. There is a possibility that your data might not have that value. That value is missing, so it is going to raise exception. So here at this point we have to manage that exception. So for example, if you look at the file we are talking about, this file has these values, and you see that some of these values are missing. So this is empty, similarly this is empty, this is empty. So if in your data something is missing, you have to skip that part. We don't care, let's say if we have thousands of values, and if there are 3, 4, 5 are missing, then that are not going to have any impact on the inferences we are going to draw from that data. So we just want to skip them, and we want to work for rest of the data. For that we use try except block. Remember, we have talked about exception handling in some of the previous lectures, so let's use that here. So I'm going to use this try. So try block here. Let's say if this value is missing, then it's going to raise an exception, and that exception is going to be value error. Similarly, tmin line, we want to read the next entry of this line, which is the minimum temperature. So if any of those two entries are missing, it is going to raise exception, and that exception is value error exception. So except name of the exception is value error. So when exception occurs here, you can write anything you want. What do you want to do when exception occurs? So we don't want to anything, we just want to continue the process. So I'll just write here continue. So continue simply means if something happens, just go back and read the next line. We have also talked about this continue statement in our class. So okay, so we are done here, and then we have to use this else. If suppose you are able to read these lines, or if you are able to convert this into integer, that means there is a value present here, that's why you are able to convert this into integer. So in that case we can read that value and append those values in these two lists. So for that we have to write it here. So high temperature, so in this list append this value. So high temperature is this line 4, sorry, this is line 5. So fourth entry is the highest temperature, so int line, and we are going to read the fourth entry here. Similarly, just copy this and paste it here, and now we want to read the fifth entry. Fifth entry is the minimum temperature, that is going to be appended in this list. But now we also have to record the dates, corresponding dates. That's why we have an empty list by the name of date. So in this list we are going to store the date. As we have converted all these entries into integer, we have to also do same kind of thing with the date, because when you read the date is going to be in the form of string. So we have to convert that date into some kind of object that we can use to plot the graph, because the dates are going to come on the x-axis. For that we have to use a module, and name of the module is date time. So we have to import that. Import. Using this module you can handle different formats of the dates. So date time, from date time import date time. Actually date time is the name of the module, and this module also has a class by the name of date time. That's why they have same names. Now we are going to use this date time class to handle the date format here. So from this date time class we are going to use str p time. So this function does is it takes date in a certain format in the form of string. So in this function we have to pass the dates that we are going to read from this file. Date is going to be the second index of each line. So this should be line and second index. So this is going to be a date, but date is going to be in the string form. If you look at here in this file, you see that so we are reading this line and this line is in string format. So we have to convert that into some different format that can be used to plot the graphs. Okay, so and there you can use this string p time functions to convert this date string to any other format. So we are going to convert that into a format. So there are a number of formats available. So percentage year. So here we are going to place the year. So we are writing hyphen here because this string contains hyphen. So we are saying that before first hyphen, whatever you have should come here. Then after that hyphen, whatever you have should come here. And then after that hyphen, whatever you have should come here. So here will come the year. Then here you have month. And at this point, day is going to be printed. So this string will be converted into this format. And this is a date format which can be used to draw graphs, while dates are taken on x-axis on this in this format. So this is going to return an object. Let's call it new date. So new date simply means the new format of date. So new date means just we have changed the format of the date. Again, let me just explain. This line 2 is a date entry that is in the form of string. You can't use that date entry in this format to plot a graph. So we have to convert that date entry into this format. And this function returns a date as an object, and we have given that object a name new_date. So now this format of the date can be used to plot graphs. So, and I'm going to store that or append that date, new date in this list, date.append. What we are going to append is new date. So now we have these lists ready. First list has high temperature list has all the temperature, all the highest temperature. Low temp has all the lowest temperature. Date has all the dates in the correct format. Now we are ready to plot this graph. So in order to plot, again we have to construct figure object and axis object, but these are going to be in 2 dimension because they are 2-dimensional graphs. So ax comma fig, this is going to be plt.subplot. So you can leave all the optional arguments as default. So ax dot plot, so we are going to plot first date and high temp, and let's assign a color to this, and suppose the color is red, and then we plot on the same axis, we plot date and low temp, and suppose the color is green. So this is just a simply basic plot. You can have all kind of labels, titles, fancy things for this graph. So let's first run this and see what we get before we add labels and titles to this graph. So let's save it and run it. There is an error here. So I have made mistake here. So this should be in correct order. So first it should be figure and the second should be ax. So this is a kind of tuple, and you know that in tuple the order matters. So save it and run it again. So you see that we get this graph. So the 2 curves have been plotted, but the data is huge. If you look at here on the x-axis, data has been taken from 1970 to 2020. So let's first plot a small amount of data so that we can see things clearly. Let's first take only 30 days data. So how do we do that? So you can have some iterator here. For example, let's say k is equal to 0. And here you add, every time you go inside the loop, you add k is equal to k plus 1. So every time you go inside this loop, every time you come here, you're actually reading the data for the next day. So here you can have a if statement if k is equal to 30. Let's say if k has reached 30, I would say that break. It is going to break it and come out of the loop. So we are going to have data for 30 days. There has to be 31 here. So first time when you enter, you get k is equal to 1, and then you do all the process, and then you come back k is 2. So when k is 30, you will still record the data, but when k has become 31, it's going to break and come out of the loop. So let's now plot this. So we get this data. Now you see that we have all the dates. They're not just years. We have years, month, and date. So you see that we have data from month 1, data of month 1 1971, and we record these values starting from 1 to 30. So this curve shows the highest temperature, this curve shows the lowest temperature. You can also set the date format. For example, if you have so many values here, this date format takes more space, but if you make them diagonal, then it would be easier to plot more values without changing the date format. So for that we have a method, and that method is for the figure. So figure auto format x date. So using this method you can format your date diagonally. So let's run this and see what we get. So you see that now dates have been formatted diagonally. So you can add even more dates here. It allows you more space. Now let's add some labels and some title to this graph, legend for this graph, and you can fill up this area with some color shade, and you can add more values to this data. So let's do that. So let's include more values. For example, we include, let's say, 100 values, and here I can add access.legend. For that we use this legend function, and it takes argument in the form of list, where this is going to be the high temperature. Let's say high temperature. This is going to be title for the first graph, legend for the first graph, and this is going to be for the second graph, low temperature. Okay, now let's add some title. So ax dot set some label, set x label. So here we set years. You may set the font size. You make it bold if you want to make it bold. So for bold text we use this font weight keyword, and here you can set bold, and similarly you can set the font size. Let's say we set it to be 9, and let's copy this and use this for y-axis. So here we have set the label for x-axis, and we have set the font size, and we have made the font bold. Similarly, we have set the title for y-axis, its temperature in F, and we have used the same specification as for x-axis, and we have set the title for the entire axis. And let's save it and run it and see what we get. So you see that now the graph looks even more nicer. So we have years. You may increase even font size more. So and you can also make this bold because this is a title. So let's fill up this gap with some shade, and then it will look more nicer and more readable. So let's do that. For that we have a function. So function name is fill underscore between. Here you have to specify the independent variable, which is date, and you have to specify the next dependent variable. So it is high. For us it is high temperature, and the next is low temperature. Here you can decide which color do you want to fill up that gap between the two curves, and what should be the transparency of that. So let's save it and run it and see what we get. So you see that this has been filled with some shade, and this is default color. We may change this to any color. We can change the how transparent you want this color to be. So there's a optional argument here. It's called alpha. What you have seen is has value 1. So default value is 1. You can change this to, let's say, 0.5. Then it is going to be more transparent. And if you increase the value, it's going to be more opaque. And you can use this argument. We haven't used this argument for any of the previous graphs, but you can use this argument for all of the functions we have used. You can use that argument here in the contour function. You may also use that same argument alpha here in this plot surface graph. So this could be used with all of the plotting functions we have discussed so far, and many others. So let's save this and run this. So you see that now it is more transparent. So when you decrease the value, you see more transparency. But when you increase the value, you see less transparency. When you increase the value, you see more transparency in your colors. This graph is representing the data in a very nicer and informative way. You can easily check the highest temperature at any day. So this is how we can use this graphics facility we have in Python to represent different kind of data in a more useful way. So I'm going to end it for today. So now in the next lecture we are going to discuss some more libraries to handle different kind of data in Python. Thank you.